Hello, this is Keith Graham from Codasip. I'd like to introduce you to Assignment 10, Checkpoint 4. This is where you're going to be using the prediction_test software routine to validate your branch prediction circuitry. So I'd like to demonstrate two things. One is how this test can be used actually to find an error in your branch prediction. And then two, what it would look like if your branch prediction circuitry is working correctly. So let's move on into Codasip Studio. The first thing that you will have to do is comment out the halt on line 37. This will enable your program, when you actually are in the debugger, to pass or go beyond the jump prediction test that you had done in checkpoint 2. Now, I'm going to use the history table that is a function in Codasip Studio. And you can see I got the prediction test, and my Codal project is called branch prediction_core. So I'm going to launch it. And you can see I'm on the first line of code like I would expect. I got a couple breakpoints, and you can see these breakpoints as we move forward. I'm going to resume. And I'm at the no-op immediately after where the halt was. So since the halt did not occur, you can see that like this cycle count 6 should actually be on line 38 now, because line 37 did not actually execute. And you can see I'm on line or cycle 6, just like the comment specifies. Now you can also see that my X5 register is 0 as well. So let's go to my next breakpoint, which is actually in the branch prediction test. Now, this is a loop that's going to actually loop 10 times. And so I've actually added down here, if the branch prediction is working correctly, what the cycle count should be on each of these iterations. So I'm going to actually just step through this, and let's see how this works. This is the case that I've actually created an error so that in my core, even if I did a branch prediction, I'm still going to do the branch anyway in my memory stage, which is incorrect. If you do the branch prediction and the result was true, you should not do the branch in the memory stage, because you've already implemented the branch. So let's see how this would look. So I'm going to step through, and I'm at my first branch statement, and it says it should be 16. It's 16. It's looking good, but of course I haven't done any branches yet. And then if you notice, looks like I do a branch, and then I'm continuing. I'm not going through 10. So the test will actually do 10 loops. The loop is going to occur 10 times, 10 iterations. You can see that I've not done 10 iterations, so this is going to fail. I'm just going to continue down to its halt statement. And you can see that I should be getting here, if I have predicted correctly, 52 cycles. If no prediction, I think it's actually 70 cycles, but you can see that I'm on cycle 25. I'm going to leave it. So I have an error, and I have to debug. And I know what my error is, so I'm going to correct it and then get back in and show you what it looks like when you actually have a correct implementation of branch prediction. I've corrected my error in my processor project for my branch prediction circuitry. I've rebuilt my CA model, and now I'm going to go through the debug and validate whether my branch prediction circuitry is operating correctly. So once again, this is my history table for using my branch prediction core with the branch prediction test. I'm going to initiate the test. I'm going to go to my breakpoints, and you can see once again I'm at the top of this loop. So increment the number of times the loop occurred, and you can see that I set it up on line 53. It's going to do 10 iterations. I'm going to stop this breakpoint for a minute, or clear that breakpoint, and I'm going to go to the loop. The first time I hit this breakpoint, I should be on 16. You can see that my cycle count is 16, and I jump one more, or do resume, should be 19, 19. I'm going to go through 10 times. And you can see that I'm now on line 46. This should be my last time through, and which means that it's a failed prediction, and now I'm going to progress outside of my loop routine. So when I get down here, there's a couple things to note. Now let's look at the register file. That x3, which was the iterations of the number of times my loop, should be 10. You can see A is the hex value of 10. Now x4 should equal to 1 because I should only executed this immediate one time, only the time that I exited. If for any reason that I was still executing that add I, even for correct branch, for example, iterations, every time I did a predicted branch, I was still doing the add I, that would be incrementing, and I would have actually a total of either 10 or 11. So once again, this validates that I've only implemented this one when I actually had the failed branch prediction and moved out of it. And I get to the halt statement, and my cycle count should be 52, and it's 52. My branch prediction circuitry is working perfect. So hopefully this video helped, and good luck.